Thank you, Randy. So being the last person to talk, I'm going to talk about a bit something different, something we've been working on and trying to get to work for quite some time, which is testing working in GeoClaw. Um, I'm going to talk a little bit about that, but I w wanted to also kind of pose something to a lot of the users here as perhaps a useful tool for reproducibility in their own workflows. Um, so a lot of us, and actually just saw two different examples and many different examples over the past day. We kind of follow this general common GeoCloud workflow. You copy an example, you tweak the parameters, maybe a lot. You run it, you inspect the plots, and then you repeat and hope that it works. Um, so this is how I use it. I mean, why reinvent another example? Um, and then there's another part of this is so you do one run and you do another run, and maybe you put it in a different folder or you copy it somewhere and then you do another run. And so now you have like five different runs and you want to compare all those runs. This is a common thing for all of us. Maybe there's a different way to do this that might actually align well with your workflow. Um, so there's lots of different pain points here that we're trying to address. One is that this gets painful. It's hard to manage a lot of these different files. If you really want to do systematic comparisons, that's difficult beyond plotting. Maybe you want to automate some of that. And it's really easy to break anything. You try and change even some different parameters, things go haywire, or maybe you change something else, but you had some result that you wanted to keep and build off of. That's still hard to maintain. So we really want to say, what did I exactly change? Did it break things? Or maybe if I'm looking backwards, is that okay? Or maybe you wrote a paper and you wanted to reproduce those results and then just have simple tests that you don't have to always check what the plots are. That's absolutely a great way to do it, but there's other ways we can also automate this, especially on we're using GitHub as well. So what do we want to do instead? We want to rerun the same setup reliably. Um, we want to compare runs automatically. And kind of if it's just reproducibility we're after, that's great. But there's also the other part of this is that if we want to, we can set up one example and then do experiments that again actually build in that reproducibility automatically in what we're looking at. Um, so that'd be great, right? I mean, like, say I wanted to do a bunch of experiments on resolution or AMR levels or sea level or whatever is in that set run file, or even different topography files or storm files, whatever it can be. Anything that can basically be done programmatically right now. So what the kind of different workflow I'm proposing here is you define a setup. Say you have a set run up high, even just copied from an existing example or something you've already set up, you're pretty happy with. Um, you run simulations, and then you compare results. Okay, so at some point, we want to have this chain to be explicit and be able to check multiple different things. And what the key here is that you can still make plots, but we want to check things like gauges. So in testing, and this is what they really came up with, is we'd actually look at gauges in GeoCloud runs in order to make sure they don't change. So 10 to the -6 type things, or you can control that. We look at gauges. We actually look at full output files, so frames. We look at FG max files. There's all sorts of things we actually have built into GeoClaw and ClawPack in general to do that testing. Once that's all explicit, exactly what you're testing, the data that you're saving off the side, hopefully it's not too big, you can repeat that as much as you want. So we got to define a setup, run the simulation, compare the results, and repeat. We want to make this easy for us. So we're going to actually treat simulation runs as repeatable checks. Okay. So, and what we're going to do, this is kind of the big thing that I'm proposing, perhaps to simplify your own workflow, is use the facility for testing that's in PyTest, which is what we use now for GeoClaw, I'm going to use. and then compare to a reference. Okay, so that means that you can say, I have a default run. I'll just take sea level. So you have a default run at a sea level. You know what that looks like, and then you want to perturb it around that value, or and then you want to maybe change some AMR levels. You want to just make sure that things are changing in a way you expect, or they're not changing in ways uh, that you also don't want them to change. So the way that this looks like, and this is the proposed way to set up tests in GeoCloud now. So there's going to be lots of example code because all the tests that are there today will be running this. Is you specify this runner. So basically, it kind of uh, organizes everything for you. You have it set the data, so that's just running set run.py. It creates all the data for that. And then write data would write that data to the file. So we basically, when you do make.output or make.data, actually, this is what it's doing. We're actually just taking control of these two steps, making it explicit so that we can come in here and say, okay, this set run.py may have been your default file, but now I want to tweak just one parameter in that file. So instead of doing what I do, and that's comment out the line that you want to comment out, so you still have a record of what the number of cells say you want it at the base, the courses level, is you can actually just explicitly say, I want you to change this, or maybe even, I want you to run 5 different experiments all the time to do comparisons and say, I want you to multiply by a factor of 2 on the course level, or maybe you want to change the ratios, whatever you want to do. This allows you to do all of that at the testing time or the experiment time. This also builds code so you can actually inject, like, I want to change over to this other QInit file, or you can write Fortran, you can do kind of whatever. This is also all in Python, clearly, so you can do that and run the code. One of the things that I do want to emphasize here is that if you do have a workflow in GitHub, um, all of this is being set up so that you can actually easily, if you have your own repository, run it in the GitHub continuous integration. So there's actions on there that automatically get triggered every time you do a push to GitHub or Git, and it'll run it and compare it and say, does this changed? And it'll warn you. So all of that kind of infrastructure that we've built is actually available to you in this type of way, and kind of hopefully a fairly transparent, but also not a heavy lift. So we can all do sorts of checks. So that this is an example from both Slosh explicitly actually checking. We're adding a gauge to this, and this might be different actually than the bold slosh set run.py that's in there. We also then check some gauges. And so we have gauge ID equals 1. So we're checking gauge 1. And you can say what indices you want to check. So maybe there's a bunch of indices that you're saving out. You only have to check a few of them. You can check all of them. Depends on what you want to do. There's other things you can do. In this particular case, in the testing code, we actually generate topography. So I removed that from my talk. I was going to talk about testing topography. That's a capability. It's not well advertised in GeoClaw, but you can actually have GeoClaw have analytic topography, say a simple shelf or something like that. But you can also generate it just using a Python script. So trying to take over the role of like a make topo or something. And these other things are just basically what we're doing. You can also do this parameterization. So in the testing for Hurricane Ike, which is used for testing the storm surge, you can set up parameterization. So in this particular case, I have 2 different cases to run. One that has num cells equal 29 and 24. I have AMR levels max to 2 and num output times to 1. So that's actually what we're using for testing right now. You could also label it. I did it to course here. And I have another test that's 116.96. It's a full-on run. I'm labeling it fine just because it's useful. And you can also use these markers called slow. So you can define your own markers all you want. But the nice thing there is, like, if you only want to run the quick tests, you say PyTest, don't run slow tests. It'll work. It'll only run those tests as you want. So this allows you different levels if you'd like. But the nice thing is if you use this code, these examples, you can actually have PyTest run, as many tests as you want to define. And you could do all this programmatically. You'll notice that this is just a list of these parameterizations. Those are easily programmable. So if you wanted to do factors of 2 to the whatever, a bunch of things, you could generate these cases very fast. Again, because we are actually using the set run files themselves as the basis, then all you have to do is change the ones that you're interested in. So it actually makes this script, even with this complexity, is only still 20 to 30 lines of Python code to run. So I do want to emphasize, so a lot of the stuff I am saying is focused a little bit more on the developers of GeoClaw and making sure if we do add changes, that we're not breaking things for everybody who's a user. But this is also not, this could be useful, this is my argument, for users if you want to try to set up and have regression tests of your own on your own examples. You don't have to write these complex testing. You really actually don't even have to make sure, like, test it against regression data if you want. You can if you want, like, but it allows you to have a mechanism for rerunning cases cleanly, having comparisons if you want, and also actually kind of branching off from the experiments that you want to do and kind of labeling them as they come out. There's a lot of different options here. And again, because we're building in GitHub Actions into all of this, you can actually have a lot of really nice things run up in the cloud. For instance, actually, one thing that I think is really neat is right now we're going to be testing GeoClaw on Linux, on the Mac, different versions of GCC, the Intel compiler. So we're starting to actually see if our codes run how we think that they do and testing them actively, even different versions of Python if you'd like. So all of this is going to be, you could tweak to your own interests if you'd like. So from tests to workflows, which is kind of what we're talking about here, we still want small repeatable runs. So that's kind of defining the basic thing. So we have define a setup, running them and comparing them possibly. But then if you want to do larger structured experiments, which is kind of what I think I see as kind of the big win here, you can do the same thing, take that defined setup, but then you tweak each of those experiments to do exactly what you want. And instead of comparing data, for instance, to make sure that the regressions are working, you can actually analyze data. So you can take in all of the output, have it write out, and then output something that says, well, actually, this large set of experiments is giving me this in the aggregate, or doing, you could just make a plot. So actually, the PyVista stuff that was just presented, that was something you could do as well. Other thing, there's a lot of other options here that I could talk about. In particular, in surge examples, there's a lot of synthetic examples. So using that synthetic topography, setting up in that particular case, a set of storms that are just tweaks of each other. There's actually a boundary condition experiment in there that you could take a look at if you were interested. There's also some interesting things about automating some of these workflows. So saying in this, again, storm surge case, here's a storm, figure out what I need, and how much of that can we automate? Not using AI, just to be clear. But a lot of this can be automated, and we kind of all have that idea that that's probably something that'll work. So the basic idea here is there's a lot of structures that's exactly the same, a lot of overhead to that, but all we need to do is change the things we really want to get at, and this should allow you a framework to do this in a really scalable, easy way. So takeaways from this, and of course we could talk forever about this. Start with an example you already trust. Do the make the run, compare the loop, repeatable. So you really have a good idea of what's going on and that you can rerun that code. And then you start parameterizing things you care about. So for instance, if you had a tsunami example that you wanted to do it on a coarse resolution that you think that it kind of looks right. So it's fine enough that it does okay. And then you can start ramping it up in resolution, do those experiments and make sure that things that you're seeing are repeatable, and those experiments are repeatable and they remain repeatable. And this can kind of grow in any or sorts of directions into a workflow that hopefully will help a lot of people in the community. And we're using this to actually test GeoClaw options and things as we go. So we're right there with you and trying to get this all to work for us. So with that, there's a bunch of pointers here. This talk is all on through the workshop page. You can just click. So it's just HTML. There's lots of different links here for a lot of this stuff. So with that, I will stop talking. And we're done for the day. Yay. Well, we can still talk.